Hello, this is FlippedHarber for Algebra 2. In this video we'll talk about section 2.7, curve fitting with linear models. Our objectives for this lesson are to fit scatterplot data using linear models, and we want to use linear models to make predictions. Our topics will include the regression, correlation, a line of best fit, and correlation coefficient. Now, a correlation, basically we can have three types. This is what we would refer to as a positive correlation, meaning that the data goes up and to the right. This data is a negative correlation, meaning that the data goes down and to the right. If we were to draw a line through this, it would have a negative slope. This data has no relative correlation. Basically, we can't say whether it's going up or down. It's just kind of random data. Our correlation coefficient, we use the letter R, tells how well a set of data fits to a model. We'll be estimating it even though there's fancy ways to calculate this true value. Now, that R value is going to be between 1 and negative 1. An R that's equal to 1 means that the data has a positive correlation, and we can draw a perfectly straight line that goes through all of the data points perfectly. A correlation value of negative 1 means that the data has a negative correlation, and we can draw a straight line that goes through all data points perfectly. Now, here we see several different R values. The first one we see is a negative correlation, so we should always guess a negative value for that. And since it's so close to being in a straight line, we want to choose or guess a value that's very close to negative 1. It's not in a perfect line, so don't choose negative 1 itself. As the data gets looser and looser, less and less from a straight line, that R value gets closer and closer to 0. Truly random data has an R value of 0. And then we see the R value start to tighten up again until again the data is almost on a straight line, so that R value is really close to 1. Now, let's try to estimate some R values. Now, what about this first data, the one that's labeled number 9? Does it have a positive correlation? Does it have a negative correlation? If it's very close to a straight line, we choose a number that's close to negative 1 or 1. What about number 10? What do you think about that one? Or 11? Well, obviously the stuff in number 9 is really close to being random data, so I would estimate an R value of 0. Number 10, it has a negative correlation, but it's not very close to being a straight line. So let's guess something like negative 0.6. Number 11, very, very tight data, very close to being in a straight line. It definitely has a positive slope, so we would guess an R value very close to 1. Now, I really don't see any point in you guys trying to guess an R value that's more than 1 decimal place. Don't guess something silly like 0.923. Just guess a single decimal place. Now let's talk about a line of best fit. Now when we talk about a line of best fit, we're talking about a linear model, a line that fits the given data. So the way you're going to go about finding a line of best fit is to start by plotting the data. Now this should be done on graph paper, just like a normal graph. And then using a ruler to make sure that you draw a nice straight line, you draw a line that splits the data evenly. Now what I mean by splits the data evenly, we should have the same number of points above and below that straight line. So basically move your ruler around until you feel like it's splitting that data right in half. Then go ahead and draw that line. Finally, you want to identify the slope of the line and an intercept, or you could just find one generic point or two generic points in order to find that slope. Do not use data points for this. Even if you have a data point on the line, don't use it. Use only points on the line you drew. So if you have to read them off of your graph, that's great. That's what you have to do. Do not use data points for this. Find points from the line. Now, Albany and Sydney are about the same distance from the equator. Make a scatter plot with Albany's temperature as the independent variable, name the type of correlation, then sketch a line of best fit and find its equation. So here we see the average minimum temperature for each month of a year for both Albany and Sydney. Now the first thing we want to do is make a scatter plot. Now it says to make Albany's temperature as the independent variable. What the independent variable is the x data basically. So they're telling us that Sydney should be on the y-axis, Albany is on the x-axis. Now, does it look like there's some sort of correlation? Well, yeah, it looks like the line has a negative slope, so it's a negative correlation. Now we're going to go ahead and try to find the equation for this line. Now again, you're not going to see me choose points that are actually from the data table. I'm going to choose points that are on my line. So let's use the point 85, 41 and the point 35, 64. We do a slope calculation. We get a slope that's equal to negative 0.46, or pretty close to negative half. We plug in to our point slope form and we get an equation y equals negative 0.46x plus 80.1. Alright, so we've gone over everything. It's now time for you to try some of the homework on your own. I'll see you in class and I'll see you online.